So we're up to this idea of a p-value. The p-value is a way to unify our approach. It'll talk about strength of evidence and strength of evidence in the direction that we care about based on the alternative. A p-value is a way of quantifying the strength of evidence against the null hypothesis in favor of HA. The p-value is a probability computed from Z based on which alternative has been chosen. So what you're going to do with your Z-value and to find the p-value depends on which HA you decided was important to you. Here it says if I pick my HA that I think the mean is larger than the usual value, I find my Z in the normal distribution and I shade to the right. It's called finding an upper tail probability. And you know what? The Z could be any place. If Z happened to be down here, then you would shade this way and get some giant number for the p-value. Fine. I better take this out of the way though. You just shade to the right. So it's called an upper tail probability. If you had chosen for your alternative, think the mean is smaller than usual, then you take your Z value wherever it falls and you shade left. That's called finding a lower tail probability. And then if you have a two-sided, a not equal to alternative, otherwise known as two-sided, because the p-value is computed by summing two tail probabilities. So you find where Z is. It's either positive or negative. You find that tail probability, then you double it as if there was another Z on the other side, symmetric across from the origin. So 0 is here, right? So I put absolute Z here. It's a way to do it. Whatever Z gets, absolute Z is positive. Take that tail probability and double it to find the p-value. Or if Z is negative, just look it up in the tables to get this tail probability and double that to get the two tails. So that's a unified way of talking about strength of evidence. It quantifies how far Z is away from 0. The further Z is away from 0 in the direction you care about, the smaller that probability will be. And we'll see how small we need in a minute. So small p-values indicate x bar is far from you in a direction that favors HA. If the p-value is small enough, we say the results are statistically significant and we reject the null hypothesis, getting close. The accepted value for significance is alpha equals 0.05. It's a probability. So 0.05 is a decent number. It's a small number. It's 1/20th of the time. So we usually look for p-values less than 0.05. So the game's going to be state your null hypothesis, state your alternative hypothesis, compute your test statistic based on the alternative, but then based on the alternative, create a p-value. Once you see the p-value compared to 0.05, keep going. If the p-value is less than 0.05, you're going to reject the null hypothesis. If the p-value is greater than 0.05, you're going to fail to reject the null hypothesis. We've now put you in a position where you can be dangerous in the world. Well, not quite, but you can analyze something where you know it comes from a normal distribution and you know what the standard deviation is, because then you can compute Z. You know how to set up a null and alternative hypotheses. You need a normal distribution for this to work, so that's a bit of a problem. And off you go. So some experimental evidence you can analyze at the moment. If you have large enough samples, then X bar will be normally distributed. You just have to know what sigma is for the population, and you can go to work. We'll be back in a minute with some more exciting details of our beginnings of hypothesis testing.